Hello everyone, in this video we are going to construct ensemble tree models using boosting function. Boosting function of the AddABAG package is used to create ensemble tree models that implement the boosting strategy. Due to the technical requirements of the AddABAG package, I will create the boosting tree model slightly different. So first we need to set our working directory. Click on here and set your working directory where your data is. And I have already set my working directory, so I'm going to import the data by using myData is equal to read.csv function and then Control Enter. And next we need to install all the required packages. Since I have all the required packages installed, I'm not going to install it, but if you want to install these packages, you need to delete the hashtag sign and install each of the packages. In order to activate these packages, we are going to run the library function. Control Enter. Because the AddABAG package requires the use of data frame class objects, we convert myData to a data frame class object using the data.frame function. We convert categorical variables such as sex and hello to factor variables as required by the software. So first we are going to type here myData is equal to data.frame myData and then Control Enter. Next myData and we choose the hello, and then here is that factor, and then here myData, and again we are going to choose hello. Control Enter. And next myData, and this time we are going to choose sex, and that is equal to s.factor, in the parentheses myData, and again we choose sex and Control Enter. We set the random seed to 1 and partition the data into training 60% and validation 40% data sets. Therefore we are going to enter here first set.seed is equal to 1, and in order to partition we create a new object called myIndex, and we use create data partition, and here inside we choose myData, and from myData we choose hello, and then next we choose the 60% 40% partitioning, and then list is equal to false, and then train set is going to be equal to myData myIndex, and validation data set is equal to myData, this time negative myIndex, and then all columns. And then we run this. We have already train set and validation set under environments pane. We use boosting function to construct the ensemble tree model using the boosting strategy. By setting the random seed to 1, you will get the same results every time. The mFinal option specifies the number of weak learners single tree models to create. So what we are going to type it here. So we are going to type first set.seed and 1 to get the same results. And here we will title our tree boosting tree is equal to boosting function. In the parentheses we choose hello is our target variable, and we use all the predictors. Data is equal to train set, and then mFinal is equal to 100. As I said before, mFinal option specifies the number of weak learners, and then we can run this code. Now next we are going to create a confusion matrix by comparing the predicted class membership and actual class membership of the validation dataset. For boosting tree models, the predict function produces a list which is composed of name predictions and which includes predicted class membership and probabilities. You can access the predicted class membership and predicted probabilities using prediction $class and prediction $prob respectively. So let's type here first prediction. So here our prediction is equal to predict boosting tree, and the set is validation set, and Control Enter. Next we will create our confusion matrix s.factor, in the parentheses prediction $class, and then comma, validation set $hello, and then positive is equal to 1, and here control enter. So we need to correct here confusion matrix, and then here we select control enter. So now you can see the results under console's pane. You can verify that accuracy rate is 0.765 and sensitivity and specificity are 0.5769 and 0.8311. Now next we need to create our performance charts, and as you know that the syntax for creating these performance charts are very similar, therefore we are going to copy them from performance charts, our script. Here we are going to get until here and then copy here. And we need to make some changes because we have here, for instance, validation $target, and this needs to be hello. And again, target, all targets needs to be replaced by our target variable. And gains table, here again, target needs to be replaced by hello. And here, cumulative lift chart, we have again target needs to be replaced by hello, and here again hello. And decile wise lift chart, again we need to change target to hello, and here we need to change hello. Let's see one more time. Here also we need to change on gains table, instead of predicted prop, it's going to be prediction $prop. We can now run at least this part. Yes, we have the gains table. Now next we can run the cumulative lift chart, and you can see on the screen the cumulative lift chart and decile wise lift chart, and finally the ROC curve. And before we run the ROC curve, we need to again change here prediction $prop, and here now we can run. So you can see that IUC value is 0.8418, and this is very similar to bagging strategy. So finally we are going to score the new 20 cases. To do that we need to import the data. This time we call it myscore is equal to read.csv in the parentheses hello, let me correct this parentheses, hello underscore score.csv, and control enter. Yes, you can see my score data here under environments pane, and we type my score is equal to data.frame my score, and next we choose my score sex variable, and that is equal to s.factor in the parentheses my score sex variable, and finally we now scoring predicted class score is equal to predict using boosting tree and use my score data. And next you can check predicted class score $class, and next underscore class score prop, and now we can run all these code. Control enter. The scoring results of the boosting ensemble model are under console's pane. The 20th case here, as you see, under predicted class underscore score is classified as a class 0 case by the boosting model. As discussed before, unlike the bagging and random forest models, the boosting model does not provide variable importance information. So this is how you can create ensemble model using boosting strategy. Thank you for watching this video.